Good morning, everybody. Today's episode of The Roll-Up is with Ethan, aka Tabasco from Particle Network. Today we are talking about how Particle makes chain abstraction easy through universal accounts. Before we get into today's episode, please enjoy a word from our sponsors. Enjoy. Cartesi is your home for app-specific rollups. At the forefront of developing new tools and platforms that enhance the capabilities of blockchain technology, Cartesi enables applications that are flexible and built to scale. Build on a full Linux environment and use traditional software libraries, but in blockchain development. Go to cartesi.io, that's cartesi.io, to learn more about building your own app chain today.
Welcome back to The Roll-Up. Today we have a podcast about chain abstraction, which we kind of think is like this recipe for, if you have all these modular ingredients, chain abstraction is almost like putting them into a cookbook and allowing them to work together and giving a functional UX. This weekend I overheard a couple of my friends talking about like onboarding to crypto, and the biggest thing has consistently been the UX. So I think that's going to be the focus of today's conversation with Ethan, also known as Tabasco, from Particle Network. I think today we're going to try to define chain abstraction, talk about some of the layers of the stack, talk about kind of this like intersection of modularity and chain abstraction, and maybe ask Rob about his golf game. Rob, welcome to the show, sir, as always.
Shot 49 on 9 holes. Which is on pace for under 100, which means it's progress from the 113 that I shot the time before that. Yeah, man. I mean, I'm glad you're cooking, dude. That modular cookbook is really chef. That's real chef material right there. And I tend to agree. I tend to think that modularity and this unbundling leads to a potential issue of fragmentation, which chain abstraction could solve by linking all of these pieces together and really tying everything together into a nice, fully fleshed out meal that tastes really nice for the end user, comprised of all these modular ingredients. Ethan, welcome to the Roll-Up Cooking Show. It's an absolute pleasure to have you on, and can't wait to see what you got cooking, man. Welcome.
Yeah, appreciate it. Thanks for having me on. I'm excited to cook a modular meal with you guys today. I think there's a lot of interesting angles to chain abstraction. You guys basically had a pretty good analogy for it there. I really do think that, as we'll get into it later, chain abstraction is a very good mechanism for kind of engaging modular expansion and actually enabling it to proliferate in a way that's sustainable and kind of ready for consumers. So I'm sure we'll get into all the angles in a little bit, but we're really excited about this. And I think it's one of the largest narratives right now for a good reason. I think it has a lot of really good practical implications. So looking forward to getting into it with you guys here.
Yeah, I mean, that was fully off the top of our heads. I mean, that just came to me as I was introducing Rob to his own podcast. You guys put out a really interesting article, kind of defining chain abstraction. I think that's a really good place to start. Like, it's kind of a weird term. Even the word abstraction itself is almost like something that you don't really hear in, I guess, like the normal day-to-day world. But in crypto, it kind of makes sense, like abstracting away complexities. So yeah, you guys put out this article defining chain abstraction. I think that'd be a good place to start. And maybe we can talk about a little bit of the why behind that, and set the foundation for what chain abstraction really means.
Yeah, so I guess I can start with maybe kind of like a simple explanation of like what chain abstraction is, and I'll get into the definition that we propose, because chain abstraction, as most people have kind of heard of loosely, has an interesting idea attached to it. But one of the issues is that there's not really like a structured or like rigid way of really understanding what chain abstraction is from like a semantic standpoint. So what we did with this article is we basically introduced like, here's like a rigid understanding of like, this is exactly how you can define chain abstraction in like 7 or 8 words. But to start with like a general overview, I guess to even take us another step back with some context, Web3 for a while has kind of started moving into this idea of, 1,000 rollups, 10,000 rollups, where like actually the future, especially like within the Ethereum ecosystem, is that scaling happens through the means of like, sovereign blockchains or rollups or things that are not really confined within one single modular blockchain monolithic blockchain, because what happened for a long time is that there's kind of this idea, especially a few years back, that there's going to be one blockchain that was going to win the blockchain race, or one or two blockchains that were going to yield all the adoption. We're going to be the state machine for all of crypto. And you have all the major contenders. Ethereum v Solana has been like a big conversation recently, and all stuff. But like for a long time, this idea really was that like there's going to be a few crypto currencies and a few blockchains that are really going to be the main ones, kind of like search engines or something like that. But people realized pretty quickly that this is not a. I mean, I won't like be too crass, I guess, but I say people realize that like it's not a very sustainable way to scale a lot of time, especially like within the Ethereum ecosystem, because Ethereum itself is very limited in terms of what you can build purely on top of Ethereum itself. And we saw this with a lot of issues as people started building applications, and even like you had side chains or whatever, like other even L1s that experienced similar issues and started scaling versus alternative means, which almost always, especially in the Ethereum ecosystem, resulted in scaling via application specific blockchains. You even saw this like a lot. Like I think Avalanche was a pretty good first contender to this, that like really embraced this idea of app chains with subnets, for example. And of course, you've had rollups for a long time in Ethereum ecosystem. Now you have this idea of like L2s, L3s, and even like sovereign blockchains, sovereign rollups, stuff like this. There's a lot of like really interesting methods to scaling Ethereum, and ultimately all boils down to this idea that we're moving in the direction of having a very high volume of blockchains. So 1,000, 10,000 rollups, even L1s, L2s, that create this ultimate issue of fragmentation. Now, fragmentation specifically refers to the idea that as a user, there's number one, liquidity fragmentation. So my liquidity, my balances across chains are fragmented within certain siloed blockchains. So if I have 100 USDT on Ethereum, then this 100 USDT, I can only use it on Ethereum. I can't use this on Arbitrum or Base or whatever, because they're different environments, right? So my value, my balance is fragmented across every specific blockchain, which is a big issue. If we have 10,000 rollups, as a user, I can imagine requiring users to require them or to ask them to like cognitively manage balances across even 10 different chains, let alone if they're using 100 applications. So this is a pretty major issue. And then further than this, not only the fragmentation itself is that to like move balances across chains. So if as a user, if I don't want to deposit new funds on every application that I'm using across every chain, then now I need to go and bridge funds manually. Now, bridging itself is a relatively, in my opinion, somewhat complicated and low-level primitive that we're requiring users to do. And this has resulted in a lot of like sometimes security issues on like more user-facing bridges. You have a lot of just like general friction. Sometimes it can be slow, it can be expensive, stuff like this. So from a user perspective, there's a lot of issues around complexity with needing to move funds across chains, and like just a lot that we're asking for them to manage cognitively their balances across chains. So in any future where we want 10,000 rollups, asking users to manage their balances across every rollup that they're using and bridge across every rollup that they want to move funds across, this is an inherently unsustainable and not a feasible way to scale Web3. So if we want
this
type of...
And Sebastian, just real quick, I was going to say, prior to you just going forward on kind of where we're headed with the scale, with bridging right now, I was kind of memeing around with you, I think, on a live stream about this, where my current iteration of chain abstraction is like I go on Rabby and I go to an app that I know I have funds on a different chain on, and then I just click the button and it says, oh, here, just click here and you switch your network, done, boom, and it knows where my funds are, and boom. Like that's actually like really freaking good. Like that makes that difference is a huge difference from like MetaMask to Rabby. So like this next iteration where I think you're about to kind of take us through with this definition of chain abstraction is like even that, but even abstracting it away like completely.
Exactly. Yeah. So like there has been like a lot of initial implementations all based around kind of this idea that, there's a lot of blockchains that we're using, and to reduce the friction or the fragmentation across these chains, which I think Rabby is more centered around the friction. I think you still have the issue of fragmentation, but they make it easier because that friction is reduced to some degree. But like the whole idea of chain abstraction, like with this context established, is that a user should be able to interact across these 10,000 rollups, these however many new chains that are being created, without needing to really know what chain that they're on, or specifically like if we're going to get like more formal about it, it's really the user should be able to interact across chains without the manual processes associated with this interaction. So they shouldn't need to bridge across chains manually. They shouldn't need to manage their balances across chains. So they shouldn't need to like think about where's my USDT, how much do I need to bridge across chain A, chain B, chain C, chain D to get this this balance on chain E to do this transaction. They should just use applications, and this can usually materialize in a way where users are actually unaware of the chains that they're using, where they just deposit funds and then they go to whatever chains that they're leveraging, app chain A, app chain B, app chain C, whatever, even like larger blockchains like Ethereum, and they just leverage applications, and that's it. So they don't need to manage where their balances are. They don't need to bridge. They just have their funds and then they use it. So this is a really big part of the whole chain abstraction idea, which is ultimately kind of the separation of the infrastructure, the underlying chains, from the user experience, which is this idea of being able to use any application with your funds from any chain. So this is like ultimately how chain abstraction boils down. It's kind of the streamlining of user experience across chains to where users are no longer bound to an ecosystem. So actually, the whole idea of chains themselves turns into what it should be originally, in my opinion, is like a largely developer-facing infrastructural component. So users are now unaware, or theoretically they don't need to be, but in most cases they can be unaware of, I don't care what chain this application is using. It's up to the developer. The developer should be focused on what chain they're using because that impacts the efficiency and the resilience of their application. So chains are transitioning under a chain abstraction model from actually a largely user-facing thing where users need to decide what chain do I want to deposit my funds onto, what chain do I want to interact with the ecosystem of, what chain do I want to support, to actually removing all of this. And now chains are purely a developer-facing thing where developers, they choose what chain they want to use, whether that's an existing kind of like more public blockchain or whether that's like their own app chain. And they choose this based upon the needs of their application, not where are the users, where are the liquidity. And the users, they don't even care about choosing chains. It's not a part of their experience anymore. They choose applications. So this has a lot of really interesting applications that we can get into later in terms of like what this actually means for the ecosystem. But ultimately, this is how you can understand chain abstraction, is purely just the removal of the confines of specific blockchains from end users and allowing them to have this experience that exceeds any specific chain into being a more kind of like Web 2 like experience where they just have their balance, they go to whatever application across any chain and they use it. Forget bridges, forget specific blockchains. This is kind of the end of that. So within our definition article, going back to what I mentioned earlier, which is that this idea of chain abstraction is used a lot now. It's actually quite a popular narrative. But the problem is that there's not really a very rigid understanding of like what is chain abstraction and what is not chain abstraction. It's like, is chain abstraction just like cross chain, or is chain abstraction bridging, or is chain abstraction message passing? So to clarify this, what we did actually just a few days ago at Particle is we released an article which kind of dives really deeply into exactly what chain abstraction is and how you can understand it as a user, as an investor, as a developer. And we kind of propose this one sentence definition that we believe encompasses chain abstraction pretty well, which is just simply a user experience exempt from the manual processes required to interact with multiple chains. So it's basically
One
what I
more
just mentioned.
time, a user experience exempt from the manual processes of interacting between chains.
Basically, yeah. A user
Almost,
experience
just a
exempt
couple
from
words.
almost, yeah, just like 2 words there. Just a user experience exempt from the manual processes required to interact with multiple chains. So you can understand these manual
Bridging, switching
processes as
RPCs, etc.
exactly needing to manage
So,
multiple balances, stuff like that.
so that's chain abstraction from like the broadest sense possible. Like that's the biggest idea that everybody who's working in chain abstraction is effectively working towards.
Exactly, yeah. So the definition we chose doesn't specify what technology will enable chain abstraction because actually I believe it was Connects who originally had this idea, and I think they expressed it really well. I guess they're not Connects anymore; it's Everclear. And they had this idea that chain abstraction is defined as an experience. So chain abstraction is actually not a specific technology or set of technologies that we can use as a definition. Rather, chain abstraction is better understood as purely an experience that we can, as a vertical, as an industry, work towards, right? So this experience is defined by, what I mentioned, an experience that is ultimately exempt from any, manual processes that you have to usually do to interact with multiple chains. So it's basically taking this experience and adapting it to the same experience that you have interacting with a single chain, right? So it's like whatever you typically do with Ethereum, you can now do this like across the entire ecosystem, and it feels like you're just using Ethereum or just using Arbitrum or whatever. But you have this kind of like single chain UX. And so I really like the idea that kind of Connects proposed a while back, which is that chain abstraction is ultimately an experience, and this is how it can be defined, this is how it can be understood. And that way, as a vertical, we can build towards an experience and not confine it to it's only intents, or it's only signature aggregation, or it's only account abstraction, or whatever. It's a lot of different technologies, and there's a lot of different approaches to it. So this is why we chose the definition, and it's a pretty interesting vertical right now. And of course, there's a lot of people working towards it.
Yeah, we had Leah on from Everclear, and it was a live stream with around interoperability, and I remember a lot of the core idea is that it's like we know what it should feel like, and so it's this experience that we can kind of like picture in our minds of how we would experience using these on-chain applications, and we know that like we want it to be easy, seamless. It really shouldn't take a lot of like switching RPCs, bridging chains. A lot of that should just be happening behind the scenes. And so I think chain abstraction, like just to kind of reiterate what I remember hearing there, was that we know what it should feel like, but we don't know how it works or how it will work. And so I think when we untangle, like, okay, we all kind of like know what this experience should feel like, how like we will interact with it. And then we kind of untangle like what needs to happen underneath the hood to achieve such an experience. That's when it gets like really, really messy. There's a lot of moving parts. And so to untangle some of that, like there's a couple of things that like come to mind where, I think one of these ideas of chain abstraction is to remove bridging, make it so that, we can just click an application and we want to do some interaction. And then the rest of that happens kind of underneath the hood on our behalf. And so to achieve that, my mind is like, all right, well, I know what I want that to feel like, but does that mean that like, in order to remove bridging, does like all of the liquidity need to be in one pool and then we draw from it? Like if we were to break this down from a more like practical standpoint of implementation, right? How are we going to achieve this ideal experience that we can all sort of like feel like we know what we want? How do we end up actually going about and achieving that? You guys have done work alongside some of like the more research oriented groups like the Cake Working Group. How are you seeing implementation work with some of the other chain abstraction projects? Ultimately, like how are you seeing this play out on a practical basis?
Yeah, it's a good question. And I think first of all, you mentioned kind of the removal of bridges, and I think it's important to specify. And I forget who said it. I think it was somebody from Lefi today, or I don't know if that's how you pronounce it. I always pronounce it incorrectly, but somebody from Lefi. They posted this on Twitter today about like how one thing about chain abstraction that people usually consider it to be like the removal of bridges, when actually I think chain abstraction is better understood as like actually bridges to a pretty significant degree are still maintained. So Lefi, Skip, all these different kind of like more bridging focused organizations which kind of facilitate cross-chain transactions, these aren't lost at all. Like chain abstraction isn't necessarily a replacement of this.
It's an abstraction of that, right?
Exactly.
It's so that the users aren't the ones that are pulling the levers to take a bridge. It's so that those bridges are still taken, but it's abstracted away from the user's perspective.
Exactly, yeah. So it's basically like, you said it's the removal of the bridges from the user experience, so that rather these are definitely still used under the hood. You still have like a lot of message bridges, Hyperlane, Layer Zero, all these guys, as well as like more token-based bridges, and these exist, but unbeknownst to the user, right? So this is actually underneath the user experience, is handled by chain abstraction protocols. Now, there's a few ways that this is usually handled. For us, we kind of go through a few different mechanisms. We actually kind of use an alternative bridging mechanism that goes through it's more of like a liquidity bridge rather than like an actual token bridge, which we can get into a little bit later. But generally, like, I guess first it can be important to establish some context as to how chain abstraction is typically composed within like the larger stack. So chain abstraction can ultimately be understood through like three core components that create at least what we consider to be like a full chain abstracted experience. And each of these kind of constitute different levels of practical implementation that take different approaches. So number one, you have what we consider to be blockchain level chain abstraction. This includes things, at least in our opinion, and we kind of see this as being quite a compatible idea, which is like including things like Polygon's AggLayer, or the Superchain, or a Veil Nexus, right? So things that are actually infrastructurally and intrinsically connecting and unifying blockchains beyond the surface level. So this is actually like like I said, architectural connection, which, shared security, sometimes shared liquidity, unified bridging, stuff like that. That's great. And like, if this is possible, and if you can do this, like everybody has their own takes about like this approach to chain abstraction or this approach to like unification and liquidity, fragmentation reduction. Some people think it's centralized or whatever, but I think that it's a interesting approach. And like, ideally, you could imagine a world where like chain abstraction starts at this point, right? So you have like a collective of interconnected blockchains, right? So this is like step one. Now below this, you have what we call account level chain abstraction. This is actually where we sit at Particles. This is what Particle enables with what we call universal accounts, which we can talk a little bit more about later as well. But account level chain abstraction is just simply bringing chain abstraction to user accounts, which can result in kind of the universalization of balances. So I have all my balances across all chains. It's kind of sitting in this one spot. As a user, all I know is I just have these balances and I can use them wherever. So the account level chain abstraction is basically the unification of account state, account balances, and ultimately automatic like bridging and whatnot for end user accounts. Then you have below that application level chain abstraction, which is more kind of like for developers. This is more programmatic. So giving developers the ability to actually make their application intrinsically chain agnostic, which is actually a pretty cool part of chain abstraction that people don't cover as often, which is like the implications this has for developers is that they can now create applications that are not bound to any single blockchain. And using application level chain abstraction solutions, they can orchestrate and kind of create really seamless, like, and quite complex cross-chain transaction workflows. Sometimes this is based on intents. That's usually the most common. You have things like Socket. I think Socket is doing a lot of really cool things with their like MoFo protocol, and this kind of creating almost like an intent-based system for applications and developers to kind of compose across any app. They're doing some cool stuff. You have Agoric's orchestration API, which kind of like programmatically and like primarily JavaScript and kind of familiar languages allows developers to orchestrate very seamless cross-chain transactions and workflows, even do things like asynchronous timing and all this kind of more complicated, developer-facing things, and maybe a little bit too granular for this rundown. But so like, there's a lot of really cool things in there. Usually intent-based. Account level chain abstraction is sometimes intent-based. There are some solutions that kind of take that approach. We also have things like Near, which is more of like a signature aggregation idea, which is they don't use intents directly, but rather they more so allow like a single Near account or contract to kind of like own or sign transactions for accounts in other chains. You have things like Particle, which we're more focused on like an account abstraction model, where we kind of use like like one signature to then like authenticate a sequence of transactions. We use like kind of like a pseudo intent model. It's not as like intent centric as you might find other solutions to be, like more application level solutions, but we use kind of like a similar idea. Then you have some other kind of more native intent focused models. Then at the blockchain level, of course, this is very different. So that's where you have things like AggLayer, Superchain, et cetera, Nexus, which are more of kind of like, unification models, chain cooperatives or chain collectives, however you want to say it. So this is like, at least on a practical level, how you can see chain abstraction being implemented from these three different levels, all very different types of implementations, but definitely they're all equally contributing, in my opinion, to kind of the acquisition of like this complete idea.
Another cool one is Lumio, which isn't really like in this like part of connecting chain ups in this chain abstraction world, but they've got a solution where they're able to deploy a VM onto a new settlement network. And so you can take a Solana application and have it continue, stay on Solana, but also deployed onto the Superchain. And so I think this is kind of like another angle to take this progression where we're moving into a world where it's going to be basically applications. And then those applications might touch multiple different rollups or L1s as settlement networks. And then we'll have different, orchestration protocols, chain abstraction protocols that help with the back-end infrastructure of these applications, because, once they start touching multiple different rollups as settlement networks, it becomes extra complicated to try to move liquidity around and so on and so forth. And all of that will happen behind the scenes. And so these applications on the front end are going to be what the user feels and gets to know and have familiarity with. But then all of these chain abstraction infrastructures are gonna help with the movements and the transactions underneath the hood. And so you mentioned a few different levels of the stack there. I just want to reiterate, right? And this is the blockchain level, which is kind of like the smart contracts, maybe on different networks. You have the account level, which is like universal accounts, like just a single balance where I can have, all my assets might be on different accounts, but when I look at my wallet, I see that everything is on my one wallet aggregated together. And then we've got like the intent solver layer, right? Where, I interact with a blockchain and then there's a solver or a filler that fills the liquidity of my order. And then the last piece is escaping me right now. Can you remind me what that fourth piece is?
Yeah, kind of the application level with orchestration and with that's where I would probably put intents kind of like under the umbrella of the application level. So that's where you have, I would primarily say like, orchestration, which I think sometimes can kind of be considered like very adjacent to intents as well as like just intent protocols themselves. This is where, of course, you kind of get this programmatic interaction and programmatic facilitation of kind of cross-chain workflows and chain abstraction.
Awesome. And so when you guys were delving into this a definitional piece of chain abstraction, did you keep it relatively broad, or did you dive into each one of these layers? And then kind of like, what were your findings after doing the research for this piece?
Yeah, so we've had the opportunity to
welcome aboard on our journey into the singularity. This is the endgame roadmap for Frax and Fractal, the new L2 out of the Frax ecosystem that is totally based on fractal scaling. Fractal is a modular L2 blockchain built by Frax with modular and fractal scaling in mind. Fractal scaling is based on the Mandelbrot set of fractal images, and it explains how L2s become L3s and the entire app chain lifecycle goes through its evolution. The Frax ecosystem is made of some of the top builders in the space and has stemmed from its OG days of the Frax stablecoin. It is now in the LST space, the LRT space, and this Fractal L2 joins the existing suite of Frax products, including Frax Swap and Frax Lend. You can see Frax Ferry, the bridge to go from any chain, Arbitrum, Optimism, or mainnet into the Fractal mainnet, bridge your tokens, and bring your Frax assets into the Fractal ecosystem. Join today to get the best out of Fractal. You are still early. Join today, take part in our expedition into the singularity.
Like dive pretty deep into like the entire stack and communicate with pretty much every major player in the stack, which has been great because we've kind of been able to understand. Actually, like I think people typically overestimate like how big the chain abstraction vertical is. It's actually pretty small. There's not that many people building like specifically for chain abstraction. Like the main names like come at the top of my head. It's like, Polygon, Avail, Particle, Socket, Near. You have like Light Protocol, a few other guys that are kind of doing similar things. Agoric, of course, and so like it's a pretty small subgroup. But when we kind of did our research, and actually like this whole like account blockchain application, we proposed this framework, kind of created this framework with Agoric. So we kind of sat down with Agoric and we said, okay, well, we know Agoric is like an application level chain abstraction solution. We know that we're doing like kind of more account stuff. So how do we like articulate this and like make it clear that chain abstraction is more of a kind of collaborative vertical than a competitive one? It's like all my talks have been very centered around this idea that like chain abstraction is not like a monopolistic thing to be achieved by one protocol. I think, early on, there's a lot of ideas that like, a lot of people thought this, and like, I mean, for good reasons. I mean, it makes sense. It's like, who's going to be the one protocol to do chain abstraction, to like achieve chain abstraction? Like, who's going to win the chain abstraction race? But in our opinion, this idea of winning some sort of chain abstraction race is actually flawed because chain abstraction is a very ambitious goal, and it's like, I mean, just purely the idea of like removing users from the notion of having to understand or use any chain specifically is there's a lot that goes into that. And anybody that claims that, okay, we're going to do this, we're going to be the one that does chain abstraction, nobody else needs to, there's no other solutions that need to be, complementary to this, I think is usually just not a very sustainable way to look at it. And it's typically it's a lower quality way to actually achieve the problem. So typically what is a better, acquisition of this full chain abstraction idea is a collaborative approach where you have this type of stack. And this is why we actually created this idea of the stack in the first place with Agoric, which is because we realized that I think I was in Dubai and I had this conversation with Agoric, and that's when we were kind of talking through these ideas. And I was like, yeah, like we need to articulate this, and that there's multitude of solutions that need to work together to achieve chain abstraction. Because one protocol itself, I think a lot of times you achieve it, like you arrive at the same centralization problem if you just have like one single chain abstraction protocol that just kind of does everything. So that's why we kind of approach it with this idea of a stack where you have these different solutions, and we've talked to all these different players. We think that there is a lot of different ways of doing it, and I say like this idea of collaboration, not competition, but there definitely is competition still. I'm not gonna sit here and say like, oh, we're all like whatever, holding hands and building solutions. I think that there's definitely still competition, but horizontally. So what I mean by that is that you have the stack, right, and it's a vertical stack. So you have application, blockchain, account. And there's no competition vertically because these are complementary solutions. These are compatible solutions, right? If you want an account level solution, you want an application level solution, these typically work very well together. Sometimes some products will do both account and application. That kind of is a different scenario, but generally there's no competition vertically. The competition that you have within chain abstraction is horizontally. So within each layer itself, so between account level chain abstraction solutions, it's what are going to be the most adopted account level chain abstraction solutions? What are going to be the most adopted application level chain abstraction solutions? What are developers going to want to use? Right? I mean, these are things that are unavoidable. And from our research, we've seen a lot of different approaches to do this in different stacks. So like I mentioned, within application, you have intents, you have kind of more general orchestration, which I think are both a very interesting mechanism of doing it. You even have like lower level primitives, like kind of the facilitation of cross-chain bridging, which I would consider to not be like complete chain abstraction, but more of like a component of it. And then at the account level, like I said, you also have multiple approaches: signature aggregation, account abstraction, intents, stuff like this. At the blockchain level, also various different ways of doing it. With AggLayer, you have like a ZK proof aggregation, all this kind of stuff. So there's a lot of different approaches to it. And I think that through all the research that we've done, we found it to be quite it's quite cutting edge, to be honest. Like all the solutions being built in chain abstraction are like at the forefront of like general innovation Web3. And I think that's why chain abstraction, like people have known for a long time that this is a problem that needs to be solved, but hasn't really materialized until now because the technologies have kind of progressed to a point where it makes it possible. So it's quite an interesting dynamic between all other projects. And I think that ideally what we see is a modular implementation. So I say this on Twitter, I say chain abstraction is modular because I believe that like chain abstraction and its materialization will be a modular stack of solutions that you can kind of, I want to use a different account level solution, I want to use a different application level solution, whatever. And that's how it works as a developer. That's how it works as a user. I think this will be kind of the way that it goes, but who knows? I think it's quite an interesting and very quickly evolving dynamic.
Yeah, that's what I was thinking as well. The stack sounds familiar from a modular perspective. It's also interesting to think about the collaborative efforts from a vertical perspective, right? So you can have different parts within each. Like think of it as like a hamburger. You got like your buns and your lettuce and tomatoes, and then your burger. And so you kind of have these different parts, but you can try a different Angus beef. You can try a different. You can use sesame seeds, or you don't need them, right? And so but like the Angus beef isn't competing with the tomato. You know what I'm saying? It's two different. It's very important parts. So like, kind of stepping out of this analogy and back into like technical implementations without you cracking up too hard here. Like, how does this collaboration like actually work? Like how does my ag layer interact with particle? Also interacting with like a cross or like a intent based design. Like is there like a technical lift that you have to go like work with these teams on? It's like an app by app kind of cadence. And then like, how does it feel for me, or what is like the ideal like end goal for like me to feel as a result of using multiple parts of this modular sandwich?
Yeah, I think we're definitely continuing to cook that modular meal through the conversation here. Yeah, I think that it's a good point, and it's a good analogy too. Like there is definitely like I think vertically the implementation is gonna, because I think if you only have like for example an application level solution, which is like you only have like an intent system that exists at the application level, you only have orchestration. This is definitely still better than the current user experience, and it's a good way to like improve UX and make it easier for users to like leverage applications that have seamless cross-chain workflows and all this stuff. But the issue is that you still have a lot of unsolved problems. So for example, if you only have application level, then users don't have like the fragmentation problem across applications and chains still exists, because while like you might have aggregated balances or like some degree of like really high quality intent systems or whatever in one application, as soon as you move to another chain, another application that's using a totally different system, it's using different kind of like an implementation of chain abstraction or whatever, if it uses any at all, and then you're back to the same issue of like, okay, well now there's fragmentation again, right? Which is fine if you have single applications that have good UX, but the idea is that there's a compatibility here where you have account level solutions, which account level solutions exist purely to solve that, which is like create some mechanism for which users that can leverage their accounts across every application have some degree of like standard there of, okay, I can use my aggregated balance, I can use my unified balances across every app. And then each application handles the continuation of that, the actual achievement of like full chain abstraction from the like perspective of, cross-chain workflows. And, for example, I sign a transaction and it does, 10 different things for me. It puts like limit orders or whatever, maybe like, classical intent solutions and use cases. Like this is great. And I think this helps a lot, especially when it's done across chains. But you need the account level to have some degree of basis there for users to leverage the balances across chains, users to have one address and stuff like that. So I think like these are really the two most intrinsically compatible solutions. If you have one without the other, then you miss a lot. If you have only account level, then you miss a lot of the granularity and the usefulness of application level, because of course the value from that comes from the fact that applications can really tailor that to enhance their experience and become intrinsically chain agnostic. So this is where these two parts of the stack really fit well together. And then for the blockchain level, I think that I see this as usually being more of an optional layer. It's not required, but it's definitely quite helpful, especially when it comes to a lot of the problems that even I think like, account level solutions and maybe application level solutions will struggle with to some degree to start, is that even like if you have good intent systems or like, good mechanisms of moving liquidity, a lot of time you still run into the issues of like sometimes security isn't that great, sometimes it's kind of slow, because ultimately you're still dealing with like non-equivalent blockchains and trying to move funds across these blockchains, trying to communicate in a way that's equivalent. So this is really hard to do when there's no like unification of architecture across these chains. When they're all using very different things and very different implementations of kind of the stack and stuff like this, then you result in either security assumptions, trust assumptions, or you're trading this off for speed and cost and whatever it may be. So this is a big problem, right? So I think this is where blockchain level chain abstraction comes in, or the AggLayer, or whatever you want to call it, which is where if you can apply account level chain abstraction and application level chain abstraction to a collective of chains that are unified architecturally to leverage shared security or shared bridging or whatever, to where you can achieve the same stack of like, atomically moving balances across chains and doing like really quick cross-chain workflows under a way where that actually has no major security assumptions and is quick and is cheap. And this is possible primarily when you implement blockchain level chain abstraction. Without it, then you still suffer from the issue of like, how do you navigate this lack of equivalency across chains without imposing too many risks or still not improving UX because it's too slow or whatever it may be. All right, so like this is I think where a lot of the interesting collaboration comes in, where like ideally in a future you have like, at least from my perspective, and of course people would disagree with the need for blockchain level chain abstraction or the need for account level chain abstraction, whatever. But I think from my perspective, typically the way that I see it, as well as how Particle sees it, is that you'll have this future where you're going to have essentially, a blockchain collective. Let's say it's like there's something, you have like a unified rollups, for example, and these rollups are all kind of like they share some degree of like a security implementation, or they're equivalent in some way that allows for kind of the attributes that I mentioned a moment ago. Then below this, you have account level chain abstraction, which operates across this entire collective. Then you have application level chain abstraction, which operates at the applications across each application specific rollup. And now you have the ability to, number one, orchestrate really complex cross-chain transaction workflows through the means of intents or whatever else you may want to use in a way that's very cheap. It's very secure. You have accounts that can now seamlessly move balances across chains to create this universal balance, also in the same way without imposing trust assumptions or like security risks, or do so in a way that costs a lot or is slow. And like this is I think the ultimate user experience. There's always going to be some degree of like friction that's associated with it, especially when you're moving across these isolated chains. But I think chain abstraction will reduce the majority of it. It's even better if we can implement blockchain level chain abstraction and have this like complete stack of solutions. So this is how we see it. And this is why we kind of chose these different layers.
Yeah, I really like this analogy of like built like this modular sandwich. I think that was very good general overview of how these sections will fit together. And I do realize that there's also this level of like, I've heard people refer to it as like co-opetition. Like you've got to cooperate, but you also compete. And so it sounds like, we're cooperating vertically because the application has to work with the solver, has to work with the account, has to work with the blockchain. So all these layers have to work together. And then horizontally, we have competing projects that are competing to be like the solver layer or the account project that takes on chain abstraction. And so I just want to double down because I really like the analogy that Andy gave with like kind of picking like each like if you were to kind of pick a project from each layer, let's say we take particle at the account layer and then pick your three, other favorite projects at each, one for each part of the stack. Could you kind of allude to like how you could work, how particle specifically could work with, an Everclear or an Across or, whatever the project is at each part of the stack to just kind of illustrate how these, particle could work with and how these other projects could all integrate and comprehensively build this experience?
Yeah, definitely. So I think we actually, and it's good that you brought this up. I'm glad you did, because there's an article that we published with Agoric and Avail just last week, and it kind of goes into this exactly, which is what we would consider to be one of the, like a pretty good example of a complete stack, which is Agoric's orchestration API, Particle's universal accounts, and Avail Nexus. And this is where this actually occupies each part of the stack. So you have Avail Nexus for blockchain level, Particle's universal accounts for account level, and Agoric's orchestration API for application level. And so within this article that we produced, we went through a lot of different examples for how this would actually materialize. It's like, what does this actually look like on a UX level to use a solution that leverages all three?
Do we need a solver layer? Is that built in? Is there, just because I realize that's another layer of this stack, but if we have three, does that also cover the solver layer, or how do we incorporate that?
From my perspective, it generally depends on the specifics. Like I would still kind of confine it to those three layers, but I would consider, for example, a solver layer or like a clearing layer, for example, to be more so a component of solutions within those three layers. So, for example, if I have an intent system on the application level, this would then use a solver layer or something of that nature. So rather it being a full chain abstraction solution in and of itself, it's rather it's a piece of infrastructure that then exists within some sort of application or account level solution. Now, for example, at Particle with universal accounts, we do use a sort of, we call it a liquidity provider system, but it can sort of be understood as like a filler system, almost like an intent system. We don't consider it to be like a full intent system, but it's adjacent in how it functions. So we're of course in conversations with Everclear in terms of maybe using a clearing layer to some degree to manage like how we kind of rebalance and manage our fillers and stuff like that for the means of what we call universal liquidity. And of course, like I think that there's a lot of good collaboration across like the stack of solvers and intents and account level solutions and application level solutions, but there's a lot of solutions that don't use intents at all. And I think a big misconception around chain abstraction is that it's actually like a subvertical of intents. Like actually it is all intents, and I don't necessarily agree with this. I think that while a particle we do use and kind of implement like architecture adjacent to intents, I think that you have plenty of solutions that aren't intent centric that are still, I would consider to be chain abstraction solutions. Like Near is a great example of this. They're implementing this kind of chain signature idea, which is not like an intent-based system necessarily. They use MPC nodes to like sign transactions for accounts across multiple chains owned by Near contracts and Near accounts, stuff like this, which I want to say is like intrinsically is dependent upon like a solver system or something like this. So it's definitely not like a 100% required component to achieve what you could consider chain abstraction, but still, I think that it definitely fits within, like, I would say most projects are probably like they implement intents or something adjacent to intents, like many like we do and many others in the application level space do. Which that's that at that point within those solutions, that's where you see things like solver layers, or of course like the recently introduced concept of like a clearing layer actually start to take place, because those are solutions that need it. But it's not a necessity necessarily. I guess that's kind of the point I'm trying to make.
Got it. That makes sense. Yeah, it seems like those two layers that you touched on, more importantly, the application and the account layer kind of bring the majority of I mean, if we can just get to those two from where we are now, then basically what you're getting at is like the difference from going from those two to the full three. It would be an improvement, but a marginal one compared to if we went from where we are today to having both account and application level, which seems to make sense to me. Now, when it comes to specifically on the account level for universal accounts, this is something that you guys are talking about quite a bit. Still trying to wrap my head around it as well. We've heard smart accounts as well, universal accounts. Like, what is this idea of just like account abstraction and chain abstraction? It's different but similar. Like, maybe you can walk us through this landscape of like how like smart account wallets or account abstracted wallets also play a part into chain abstraction and kind of particles universal account setup.
Sure. Yeah, definitely. So, we, for some context, we focused really heavily on chain abstraction over the past, year and a half, to the point where we became like one of the largest account abstraction infrastructure providers in terms of like user operations through our bundler and paymaster infrastructure and all of our SDKs around, implementing account abstraction through different angles. So when we wanted to tackle chain abstraction, we kind of came from the angle of account abstraction. And now what's best to understand about account abstraction is, of course, very simply, it's the transition from externally owned accounts, which is kind of the traditional rigid account structure, to, of course, smart contract wallets, which are much more flexible. They're intrinsically programmable. You can do a lot of really cool things with this, gasless transactions, pop-up list transactions, whatever it may be. And so there's a lot of undeniable benefits to account abstraction. And we really like the ERC 437 standard in terms of achieving account abstraction. The issue, though, is that account abstraction is actually quite difficult to apply across the board, for example, in like a chain abstraction scenario, because account abstraction has this issue of being smart contracts. You're deploying smart contracts as accounts. Smart contracts are fragmented across chains. They're isolated. So if I have contract A on chain A, contract B on chain B, contract C on chain C, and I want to update something about the smart contract and push some sort of change to it, like a state change, for example, then I do this on chain A, and all of a sudden, now the contract on chain A is different from the contract on chain B and C. So account abstraction actually for a long time has been not very compatible with chain abstraction in terms of like its fundamental overlap, because you have this major issue of fragmentation across chains, where they're like, as soon as you change something about a smart, like the actual contract of a smart account, and at state, so like, so you change a signer, right, or you change a module or something like this on chain A, then it's immediately different from all the other deployments that it has. And also you need to like deploy across all chains and manage deployments. And it's not that easy to work with. It actually introduces some complexity. But account abstraction has a lot of really great benefits that can work really well with chain abstraction. Because with account abstraction, you have, for example, you can like delegate signing permissions. You can delegate signing authority to some third party, where like you can have them sign transactions for you, or do some other like pretty cool things that can lend pretty well to chain abstraction. Gasless transactions just improve UX overall. And the programmability makes it easy to kind of create more specific account-based solutions for chain abstraction. So what we want to tackle is, well, how do we leverage the pretty undeniable benefits of account abstraction today, but in a chain abstraction scenario? So how do we actually leverage this for chain abstraction? So what we did was we introduced universal accounts, which are our answer to chain abstraction, leveraging what we believe to be an inherently superior way of managing accounts, which is account abstraction, but doing so in a totally new way that allows for it to actually benefit and enable chain abstraction better than what we would believe to be possible with EOAs, for example. So with universal accounts, essentially what you can do is, to start with a very high level, you can have one balance you can use across all chains. So this is the very simple kind of run of the mill of it. This is account level chain abstraction. This is what we're doing. You have a universal account, you deposit funds 100 USDT on Arbitrum. You can use 100 USDT wherever you want. If I deposit 50 USDT on Arbitrum based on Ethereum, then I have 150 USDT that I can use wherever. Right? So like this is there's no distinction really, or there's no need for users to manage and individually, bridge funds or stuff like this. They have a universal balance. This is really the idea of universal account. And furthermore, they have one address that spans across all chains. And this is actually fundamentally using a smart account. So you can basically, we support a number of smart accounts, like Economy, for example, simple accounts, stuff like this, that will upgrade to being universal accounts eventually, that are made through our SDK. And this allows you to instantly use your balances across all chains, kind of have instant access. And of course, we leverage the benefits of account abstraction to do this quite intrinsically, especially, for example, like bundled user operations or bundled transactions, which actually allows us to take multiple operations. So if we want to do a swap and a transfer and X and Y and Z, we can, with account abstraction, it makes it very easy and very sustainable to actually do all of this with only one transaction, with only one ledger entry. So we can do like 4 or 5 operations And these can all be like sequential and actually like atomically insured through the means of actually having this all settle through one on-chain transaction. So there's a lot of like, this is just one part of it. You have a lot of other benefits that can actually really increase efficiency, reduce time, make it far more practical to implement chain abstraction. And so universal accounts are basically taking the benefits of account abstraction, solving all the friction associated with it, and applying it universally by introducing this idea of universal liquidity, which is just the same thing as having one balance across all chains. And you can also, with universal accounts using a similar mechanism, pay for gas fees in any token. So I want to do a transaction, I want to pay for gas fees using my, I don't know, ETH from Base, and I can do so. And it doesn't really matter. I can use any token, any transaction, and that's about it. Now, to get back to the original issue of like for smart accounts, having this lack of parity across chains with the account state. So if I want to upgrade a module assigner, et cetera, something that changes the smart account, then you have this fragmentation all of a sudden. We're also solving this. So like this is one of the main things that we wanted to solve with universal accounts beyond just kind of like the unification of balances and stuff like that. So we have actually our own Cosmos chain that we're deploying, and this Cosmos chain is very much a background component. It's not something that developers build on. It's not something that users leverage. Cosmos chain is purely a backend component. It's very much a necessity just for us to have a decentralized mechanism of coordinating cross-chain transactions with universal accounts. So what we can do is, for example, with like this idea of fragmentation across chains with smart accounts, is that because we have this Cosmos chain that exists as kind of like this central coordination layer, we can actually have and manage like account state. So if I change the signer of my smart account on chain A, then what we can do is actually on our Cosmos chain, we can like monitor this and see, okay, well, the state has changed on this chain. And then we can immediately relay updates to every other chain that the account is deployed on and maintain state parity. This is really important because this means that there's no longer the issue of fragmentation of actual like smart account state across chains, because now I just basically deploy my account and I know that basically in the background, the chain is maintaining this across every other chain, like specifically the particle Cosmos chain. And this is allowing us to therefore solve the issue of smart account fragmentation. So universal accounts, like I know I've just kind of talked for a few minutes, but basically number one, allows you to have one balance across all chains, one address across all chains, use any gas token for transactions through the same mechanism. And of course it solves the issue with account abstraction, which is the fragmentation of account state through the means of what we call our master key store hub, which is, if you guys are interested, Vitalik has some good pieces on like the idea of a key store rollup. So we take a somewhat similar approach to it in terms of kind of like unifying and like having a storage layer almost for smart accounts.
Do you see the end goal of Particle being this universal liquidity layer? Is that something that's kind of like on the roadmap further down the line? Or are you going to kind of like, are you going to just sort of like manage the liquidity across these different chains and bridge behind the scenes when users instruct Particle to do so?
You could think of it as kind of like a mix of both to some degree. So our universal liquidity mechanism basically uses a collection of essentially, like the way that I kind of convey it is just fillers basically. So it's just, entities that can, move liquidity from one chain to another by having basically pools of intermediary tokens. So the way that it works at a very high level is that as a user, I want to, do a transaction for 1 ETH on Base and I have 1 ETH on Arbitrum. So what I do is I will click confirm and wait 10, 20 seconds. And in this 10, 20 seconds, what's happening is at first, of course, through the means of like bundled transactions with, account abstraction, is that we first swap that ETH to an intermediary token. So an intermediary token in this case means USDT, USDC. So now we swap that to USDC, for example. We send this USDC to a filler that then says, okay, well, I had now received 100 USDC, and this is going to be released on Base, right? So it's from Arbitrum, it's going to be released on Base, releases the equivalent amount of Base through a pool that's maintained across both chains. It can be kind of like there's a future where this is like a bunch of decentralized operators that each maintain pools in each chain and can work with one another. This is kind of like the end goal. But the funds are released from the other chain, swapped back to the token that they want to use, ETH, for example, all again in one transaction, and then sent to their balance. So it's actually like basically 2 transactions, one to send it to the destination chain, then from the destination chain, one to send it back to the user. So it's pretty interesting. It's a very simple way of doing it. in terms of us being the universal liquidity layer, we don't really consider like Particle to be the like provisioner and like the main entity that's like handling all liquidity. We will like a big part of like our universal liquidity mechanism will definitely facilitate a lot of like liquidity management through universal accounts. But this is, again, like with all of our infrastructure, very decentralized and open for anybody to kind of like contribute, and ideally in the future, like run a pool and kind of stuff like this. So we can kind of be thought of like that to some degree, but we're also very much like, open to the compatibility with other bridges and like liquidity sources and stuff like that. So this is definitely not out of the cards either. This is kind of like how we look at it from the liquidity standpoint, and how we position ourselves.
Yeah, and I wanted to talk a little bit about the incentive structure you guys are going to set up as well. We just have a couple minutes left, so maybe we can just briefly touch on that. Any closing thoughts as to how you see like Particle Network using its own Cosmos chain to kind of decentralize, what a potential Particle token would be used for in a chain abstraction and a kind of abstraction kind of network setup. And just generally any closing thoughts.
Yeah, definitely. I'm happy to just kind of quickly touch on the actual like incentives and the network structure and stuff like that. So for example, our Cosmos chain, whenever you do a transaction, and for example, you pay for a universal gas or you do some sort of universal liquidity mechanism, it actually settles and is verified on our chain using our token. So our token kind of acts as like the primary sort of like value model incentive mechanism for the chain. It powers, of course, all the validators. So validators, they receive delegation in our native token. Our native token, every transaction is settled in the native token. So it's sort of like a value accrual mechanism. Now, this of course allows just some degree of value accrual for the particle chain itself through the means of the token. Of course, like the more transactions, the more the token is used, so the more the token is consumed. Of course, without users knowing. So users don't need to really hold their token to actually do anything with universal accounts. It's purely on the background. So all transactions they end up being settled in the token, which means that the token is consumed to the same degree that universal accounts are used. Plus, of course, used for validators. And we can touch on this just very briefly, but we also use like a dual staking mechanism because our chain, like I said, is very much like a background component that needs to be very resilient and secure. So we kind of use two sets of validators. One is secured by our token. And so like there's a lot of like ways that our token kind of fits into the picture here in terms of like operating as incentives for securing the chain, transactions being settled in this. Of course, it's the transaction fee for the chain and all this kind of stuff. So it's quite an important kind of like base infrastructural component. And of course, it gets a lot of usage just through the means of universal accounts being leveraged in general. So this is kind of like how we position our token. So yeah, quite interesting. The Cosmos chain, again, like we generally position this as like basically just being sort of like the coordination layer of sorts, at the point of of course, managing the actual account state, managing and like kind of facilitating cross-chain transaction execution, stuff like this. And of course, acting also as a point of security, versus like the alternative, like without a Cosmos chain in this example, or without like some point of like sort of like a large, decentralized infrastructure, would result in like, you could do similar things on a server, for example, but we don't see this as being a sustainable solution to chain abstraction. So we see as chain abstraction really being a decentralized construct, something that, especially on the account level, requires decentralized coordination, not some sort of off-chain entity doing everything and like facilitating transactions and solving and filling and stuff like that. It needs to be like kind of credible on-chain actors that are easy to kind of track and incentivize and stuff like this. This is really how we're trying to position our chain as being a point of centralization for universal accounts, which ultimately are the ability to leverage the kind of tagline that we've been kind of thinking about is basically one balance, one address across any chain. This is kind of the essence of universal accounts. So yeah, that's a quick rundown from the chain side and kind of how that fits into the picture.
Fantastic, man. I really appreciate you coming on and sharing insights with us today. It's been a pleasure, and I think all of us are pretty excited for a future of interacting on chain, where the chain abstraction is real. I mean, not that it's not real, but I keep asking you privately when, and I know that everyone's working on it very diligently. So quite excited to see a lot of this come out. And yeah, thanks for coming on, man.
Yep. Thanks again for having me. I was very glad to pop on these podcasts, always amazing sessions. And yeah, we're also very, very excited about chain abstraction. I think it's like going to be hopefully one of the most impactful technologies to user experience, and should hopefully drive quite a lot of value accrual for developers, for users. Of course, change the entire incentive mechanism for developers and for end users, significantly improve the user experience. So yeah, really excited about it. Of course, if anybody watching the podcast is interested in learning more, We do a lot of content at blog.particle.network. You can also check out other protocols like Socket, Agoric, people like this, Near, Everclear, also amazing projects that are building in this space. Check out Frontier Research. They do a lot of really good stuff around chain abstraction as well. Yeah, thanks again for having me, guys.